Okay, Bismillah. So the topic is actually we are going to discuss about that is your thermal, and thermal में हम लोगों ने क्या पढ़ना है, kinetic molecular model of matter या kinetic molecular model of gases भी इसको कहा जाता है. That is, it consists of three main areas what I have to discuss, and those are states of matter, molecular model, and evaporation. Actually, evaporation is, although the state of matter, yani molecules are converted from one form to another form. So I will discuss that here. So in this one, first of all, when we will discuss about the states of matter, states of matter means usually the liquids are usually the matter exists in three states. Usually, although the people say that there is four state, yes, I believe that there is four state plasma, but usually there are three states: liquid, solids, liquids, and gases, and they are interconvertible: liquids, solids, gases, and they have different properties. So if I say that why do we have these states of matter, so every material has made up of some tiny particles and atoms and the molecules, and actually these are we are unable to see these with the human eye. So that is why we just see the compact shape of them. For example, if we see a solid, we will not able to see the solid molecules or solid atoms, but we will see the solid blocks. If we would see the water, we will not see the molecules, I mean the water molecules. We will see the entire liquid at all. Gas, I mean, if it is not the dense gas or a colorful gas, we will not be able to see it ordinarily. So these are basically some sort of issues what we have, or some sort of limitations what we have in our daily life. And here is solids, liquids, and gases. They have some common areas and differences as well. So solids have, they are of fixed shape and volume. And what about the liquids? Liquids have fixed shape, but liquids have fixed volume but not fixed shape, in which they will adopt the shape of every vessel in which you keep them. And gases, they neither have fixed shape nor fixed volume, so you can put them or you can keep them in any container. They will adopt their shape of that container. If you keep pressure on them, the volume will decrease, and if you will reduce the pressure, the volume will increase. So this is actually the game of gases. Now this is the structural diagram of solid, liquids, and gases. So this is a question asked to you, that what is the arrangement of molecules or atoms and liquids, gases, and solids. So in solids, the molecules are closely packed, regular pattern, closely packed, and arranged in an order. These are three specs of solids molecules, right? Should I write this, or is it feasible for you?
No, sir, it's visible.
Visible है ना, ये बाद में मैं आपको notes पे भी भेज दूंगा, so it would be convenient for you. Just understand this and move on. And in arrangement of the particles of liquids and gases in the lower two diagrams, they have irregular pattern and further apart. And one more thing I would add here, that in liquids the molecules are arranged in the form of groups. Okay, this is very important word, that the molecules are arranged in the form of groups. But here in gases, the molecules have irregular patterns. They have wide spaces in between, and that is why they are almost free molecules. Almost free molecules. They have random motion. What do they have? Yeah, this is basically the game of motion. This slide deals with the arrangement of molecules, and this slide deals with the motion of the molecules, right? So in solids, the particles only vibrate. This is very important point. The particles only vibrate about their fixed position. What do? They vibrate about their mean position, right? Because they are closely packed, so they do not have the capacity to move here and there. They are packed enough. That's why we can simply say that they vibrate about their mean position. And secondly, in the liquids, the molecules move randomly. At low temperature, this randomness is small enough, and at higher temperature, they move more vigorously, or their random motion is vigorous. The same goes with gas particles. They are randomly moving and fast moving as compared to that of your liquids. Is it clear to all?
Yes, sir.
Okay. Then this third slide is forces. So let me uh, let me just identify this for you. I mean, I'm going to mention all that in this first slide. Just we are going to identify them. Shape and volume concept is there. Okay. In the next slide, in this slide, we are talking about their arrangement of molecules and atoms. Arrangement of atoms and molecules. Got it? And the third, yani in this slide, we talk about the motion of atoms or molecules. Okay? Is there any confusion or any question? Yes, Mariam? Yeah, Mariam, you raised your hand. Is there any confusion? Okay. Maybe it was accidentally. Maybe.
Yeah, no, sir, no, sir. No confusion.
ओके तुम छेड़छाड़ करती हो ना गूगल से, वो मुझे बता देता है. ओके, द नेक्स्ट इज this slide tells you about the force of atoms or molecules. ठीक है, atoms or molecules. So the solids have very strong force in between, yani intermolecular force. That is why they maintain their shape. The intermolecular force between the liquid molecules is fair enough, not that strong, not that weak, but fair enough. That supports them to keep their shape. And then in gases, intermolecular forces are very weak. That is why the molecules are supposed to be independent. They are not, they are unable to move here and there. Sorry. They move freely. They're not unable to move here and there. They move freely. Is it clear to all?
Yes, sir.
Okay.
Yes.
Just a second. Mhm. The next is that what about their kinetic energy? Kinetic energy. Actually, it is not potential energy. This deals with, yani these two slides will deal with energy, and especially the kinetic energy. So here I say that kinetic energy of the solids, kinetic energy is due to motion, na? Is it?
Yeah.
So if the molecules are not moving mean motion means movement, proper movement. So this is related to the kinetic energy of matter. Matter means all these three states, solid, liquid. So molecules of solids do not move. That's why it's very low. You can say it is kinetic energy of solids is zero, because they do not move. The kinetic energy of the molecules is fair at low temperature. Okay, but when you increase the temperature, it increases, right? It increases at higher temperature. Got it? And the kinetic energy of the gases is very high because they move very fast, so their kinetic energies is highest amongst the solids, I mean amongst the matters. Got it? Is this all clear?
सर आपको
Yes.
स्लाइड एक दफा और दिखा सकते हैं?
हाँ, मैं ये कह रहा हूँ कि as the kinetic energy is the function of what? Kinetic energy is the function of speed of motion. ठीक है? So kinetic energy is equals to 1 by 2 mv square. So in solids, speed is 0. So kinetic energy is equals to 0. Okay? In gases, speed is very high. So their kinetic energy is very high. In liquids, kinetic energy is fair. Fair means at low temperature, their speed is fair, so their kinetic energy is not as high as that of the gases, but significant. ठीक है ना? They can move from lower potential, I mean, lower point to the higher point. That makes them to move in the in the liquids, just like in convection and conduction. Sorry, convection currents. ठीक है ना? So is this clear to you?
Yes, sir.
Okay. The next is related to the density of the materials, yani density of the matter. So as you know that density is the function of mass per unit volume. So if I give volume fix for every for every matter, then solids have the highest density, liquids have the lower, and gases have the lowest density. Got it?
So why does solids have the highest density?
Because in a specific volume, they have a lot of mass. They have a lot of atoms inside.
Oh, so for the same amount of volume,
Yeah,
the
volume is
amount of
kept same.
particles for solids is more than that of liquid.
Yes, for same volume, solids have high density, yani more mass would be accumulated. For example, if you have a container filled with, yani this much container filled with liquid or solid, let's say just filled with solid, then what happens? Its density would be more heavier. But the same goes with liquid. If that is filled with liquid, if the same container, it would be lighter, not that much. But if it is filled with gas, it is almost lightest. Is it? Do you agree?
Yeah.
Okay. So the next is their compressibility. This is basically related to their compressibility. So when we say that solids cannot be compressed because they are closed packed, so when they are closed packed, we cannot compress them more, right? They're very difficult to compress, I mean say. Then liquids are difficult to compress. They are slightly compressed, but you will say not. They're not compressible, right? Solids and liquids at your level, you can say they are not compressible. So don't
But you
get
can
confusion.
compress liquids.
Yeah, but at your level, it would be if you are asked about the comparison, so you will say that no, liquids are not compressed.
Oh, okay.
Okay. Okay. Then gases are very easy to compress, so that they are definitely compressible, and by applying more pressure, their volume decreases and decreases and decreases. So we will talk about that inshallah in the next slide. Got it? So here we are going to discuss about the motion of the molecules and temperature, right? And then pressure in terms of molecules of the motion. This is very important question, and from here almost 3 marks question, 4 marks question is asked to you, that how you will describe or explain that the gases gases makes pressure in the container. I will talk about that in detail. So the kinetic theory of matter states that all matter is made up of the large number of tiny atoms. This is one point, I mean, one postulate or um, one idea of the kinetic molecular model. So there are different points, there are different um, ideas which were float in the kinetic model. So one of them is this, that is, yani this is one sub state of that. I'm not getting a proper word. It is basically a point of a theory. That's it. How
Point
many
of
of you took
theory.
Pakistan studies?
I did.
Okay, so there were 14 points agenda, na, or 14-point theory. What was the name
Yeah.
of that? है ना?
The Jinnah's 14 points.
Yeah, this is one of the points. Okay. So we usually called it postulates. Postulate mean any inference from that theory. 1, 2, 3, 4. We have splitted the theory into several parts. There are, देखो, what is in the law? In the law, one statement states states everything related to the law. But in the theory, there are some points which are basically divided in steps. So that is an explanation of the kinetic molecular model. So this is one explanatory point. So yani first explanatory point, that all the molecules, yani all the matter consists of tiny molecules or particles, right? There are a number of tiny molecules or particles. They are continuously moving. This is very important, that they are continuously in the state of motion.
Sir, how will the question come like to write these 2 points? Like, what will they
Right.
ask you?
Yeah, they will ask that describe the kinetic molecular model, right? This is
Oh,
the description of that. Okay, are you getting my point?
yes.
So here you have described the kinetic molecular model. So when we describe the kinetic molecular model, actually we say that is yeah, second one. Any important points in this one, you have to consider that the kinetic theory matter states that all matter is made up of large number of tiny particles. It is not large particles, large number, but tiny particles of atoms, and they are in continuous state of motion. This is important. And the existence of particles in continuous motion has been demonstrated by Brownian motion and diffusion. There are two ways or two demonstrations in which this motion was explained or observed. One of them was called Brownian motion. Brownian motion is a random motion. The second one is diffusion. Diffusion is basically, in biology. How many of you are biology students?
I am.
I am.
Oh, very good. Are you aware of osmosis and diffusion?
Yeah.
Yes. I will not ask you, don't scared of. But osmosis and diffusion mean the electrons or the particles are moving from higher concentration to the lower concentration. So if we see the movement or if we observe the motion, that is basically the evidence that there are the particles and they are continuously in the state of motion. Okay, so here is that. So motion of the molecules and temperature, right? Motion of the molecules and temperature. In this slide, actually what I tried to demonstrate, that when the temperature here, blue means low temperature, right? Blue means low temperature, and this red or pink mean high temperature. So if you see that the molecules which are these arrows or these lines show the motion of the molecules. Actually, these are the velocity vectors. When you will grow up, I will let you know if I would be there. These are the vectors which show their motion. So when the temperature is increased, the thermal energy is transferred to the molecules and the molecules gain their kinetic energy. Hence, the molecules move faster. Got it?
Yes, sir.
Yani,
Yes,
it is
sir.
very simple that the heat you provide the molecules, right? Heat is converted into their kinetic energy. And when kinetic energy will be increased, their velocity would be increased, and velocity would be increased, so they move faster. Okay. So here the molecules and yani pressure, when you uh, provide more temperature to the molecules in a closed container, this is a closed container. Okay, so what happens? The molecules vigorously move in different directions. They collide with the walls of the container and with each other randomly, and due to that, what happens? They exert force, or they transfer force from one point to another point, or from each other on the walls. That causes pressure there, or that causes an increased pressure. So very simple, very simple. If you increase the temperature, what are you increasing actually? You are increasing the velocity. When you are increasing the velocity, there would be more collisions. Is it? The collisions would be more, and when collisions would be increased, pressure would be increased. Are you getting? That is why when you place a pressure cooker for a long time on the burner, then what happens? It bursts out. ऐसा ही होता है ना?
Yeah.
Because the gas molecules, they are trapped inside, they are not getting out of that container, so that those molecules developed such a huge pressure that those molecules just uh, ruptured the walls of the container. Got it?
Yeah.
ये बात क्लियर है? प्रेशर कुकर क्यों फटता है पता है?
Yes. So,
Good.
but I have a question. That means we have more concentration.
More concentration means?
More concentration means more collisions.
Yeah, more concentration is something different. Concentration means number of molecules are greater.
How to know? If you're increasing the pressure, that means, like, for example, if there's a syringe and the syringe has a gas, and if you like push the plunger in, so that means
Uh-huh.
you're decreasing the volume and you're making the
Yes.
particles go closer together. So that will
Yeah.
be more particles in smaller volume. So wouldn't
Yeah,
that be increase
exactly.
in
Number of
concentration?
molecules per unit volume, that matters a lot. So I will talk about that how pressure is dependent, or how pressure is varying with volume. Okay, that was basically for temperature. That's why I did not consider that area. Clear?
Okay, but it is more concentration, right?
Exactly. This is your question. Check this one. Right? This is the relation between pressure and volume. So I can say that this is the relation between pressure and volume. Got it? Pressure and volume. I would like one more sentence here for you. Let me add a page. I believe that in nowadays, because initially momentum topic was not included in the syllabus, that's why most of the yani, most of the considerations are without the involvement of the momentum. But here I will talk about the involvement of the momentum basically. And momentum involvement matlab ye कि we will have a sort of, you know, I mean, what happens to the gas, or how the pressure is developed. Let's see. As I told you people that if there is a wall of a container and there is a particle or a ball striking with this wall, that ball would have a sort of, you know, velocity. ऐसे ही है ना? Is it? When it was here, it has some velocity. This way, it has some velocity because its mass is m, its velocity is u. Now it has mass, but it is stopped. And then when you will basically check this one out, that after rebound, it is reaching to this point with certain velocity in this direction, then what do you think? What happens? Is it a game of change in momentum?
Change in momentum.
Momentum
Yeah.
is final
Yeah.
momentum final minus initial momentum. ठीक है ना? So I can say that m is the mass of the particle and v plus u is the chain in velocities, because I told you simply, I will not get in detail of that here, but I told you that in case of rebound, change in momentum is equals to mass into sum of velocities. Mass into sum of velocities, because this is taking negative sign, this is taking positive sign. So when you will go to that case, minus v, yani m into v is final momentum, this minus is formula sign, this one, this one, and this one is your initial momentum. So what will happen? M into negative v, so it becomes 2mv in the negative with negative sign. So it means the particle is having opposite in motion, opposite in direction. So simply speaking, they go, it's not a big deal. I will just consider this. You are not supposed to write anything like this. You are supposed to write these 3 points. That is the pressure in gas container. This is the topic. So the question is asked, describe how or explain how the pressure is developed in the gas container. So you must know all these 4 points. Whatever I will write, that is your final. You have to recall it by all means, that gas particles have random motion. Okay? You
Got
have to
it.
mention this point. Gas particles have random motion. I mean motion in all directions. Okay? Point two, they collide with each other as well as with the walls of container. They collide with each other and walls of container. Is this second point clear? What?
Yeah.
Okay, third point. This results a change in momentum in the particles. This results a change in momentum of particles. Fourth point, change in momentum equals, yani rate of change of momentum equals to force. Do you know this thing? That rate of change of momentum equals to force?
It is derived by the force formula, is it?
उत्तर यहीं पे तुम गलती करती थी, इसलिए मैंने पूछा है. You know, you were writing momentum is equals to delta p by t. Sorry, impulse equals to delta p by t. No, the rate of change of momentum is basically delta p by t. Check करो ना. I was with my opinion that f is equals to delta p by t. यही लिखवाया था ना मैंने.
Hmm.
So that is the rate of change of momentum equals to force. Equals to force. ठीक है? Let me shift it up. Maybe I would be okay. Let me add one more point here. One more page. Will it be sufficient? No. Just a second. I will arrange it. Okay, so I was writing that stuff. The rate of change of momentum is equal to force, and force per unit area, force per unit area is pressure. Are you getting my points?
Yeah.
So total pressure is due to sum of all the forces exerted by the particles. Total pressure, this is point number 6. Total pressure is due to sum of forces. So if you remember this all detailed concept of production of pressure in the gases, you will never have any confusion, or you will never be penalized by the examiner. ये मेरी बात लाजमी याद रखनी है, ठीक है? So देखो, there is a sequence. Gas particles are moving randomly. First point. Second point मैंने क्या बताया? When they will move randomly without any sequence, आंखें बंद करके चलेंगे, so they will collide. Is it?
Yeah.
So when they collide, their directions would be changed, their momentums will be changed. So when their momentum changes, the change in momentum per unit time is equals to the force produced. Got it? Yes, agreed or not?
Yeah.
And force per unit area is equals to pressure. So the total pressure is basically, there is not a single particle. There are several particles. So the total pressure is due to sum of all the forces. Is this clear to everyone?
So, can you repeat the last point, please?
Yes, last point का मतलब ये है कि this is not a single particle, ना?
Yeah.
There are several particles. So every particle would, yani every single particle would produce its own pressure, or it would contribute its own force on the container. So there are several particles. तो इसका मतलब क्या हुआ कि there would be, the total pressure will be equal to the sum of contribution of every single particle. है ना?
Okay. Yeah.
So that is quite sequential. So yes, ये सिर्फ मरियम को समझ आया, बाकी को भी समझ आया सबको?
Got it,
Is there
sir.
no one in my class? Mashallah. Yes, Zainab बोली, अरीबा भी नहीं बोली. Okay, Boyle's law, that is relation between pressure. Sorry?
This was me, Ariba.
Oh, sorry, sir.
It's okay.
Okay. So here is a situation that when we have a piston placed in a in a closed container, and that piston is capable of motion or movement, and that piston is we have put some load on it. So when we put some load on the piston, just see that when you will increase the pressure, yani when you will put more weight on that, here we have put the same weight, no issue at all. But when you will put more weight on that, what will happen? The air will be trapped inside, and when air will be trapped inside, the pressure will be increased and volume will be decreased. So let me check that. Yes, yeah, that is that is here, explained here. Here, yeah, check this one out. Do you see what happens? That if the temperature is kept constant in this question, the most important thing is that pressure is inversely proportional to your volume. Pressure is inversely proportional to the volume. I will write the equation which is required to you. बाकी और कोई इतनी ज़्यादा डिटेल में आगे काफ़ी सारी slides हैं. So I will not go through those all slides. But here pressure is inversely proportional to volume. So when you will increase the pressure, volume of the gas would decrease. So that is why we generally say कि आपके पास if in any case pressure in case one or in state one that is equals to any constant divided by V. Any constant divided by V is very simple to understand. Any constant times 1 upon V. देखो ना, when I say that pressure is inversely proportional to volume, so can I say that it is equals to, proportional sign is removed, it is equals to K into 1 upon V. Do you agree?
Yeah.
So I can simply say that P, I mean volume at this stage for when pressure was P1, volume is V1. So P1 V1 is equals to K. Now I have changed the pressure to P2, and again the relation would be same. It is V2. So I can say that P2 V2 is equals to K. So when I join these two equations, right hand sides are same, so left hand sides would be also same. So you must have this equation in your toolkit, that is P1 V1 P1 V1 is equals to P2 V2, right? That is the equation, very common equation of the pressure. P1 V1 is equals to P2 V2, P1 V1 is equals to P2 V2, right? Mostly the student used to recall it or hifz it like this. P1 V1 is equals to P2 V2. Got it? The product of pressure and volume at any state is same as the product and volume of the other state. The reason behind that is when you are increasing the pressure, you are decreasing the space actually. So the molecules are now colliding with each other more frequently. More frequently. Do you get it? Volume कम करने का क्या नुकसान होता है? It is simply like you put all the naughty kids in small room. Then what will happen in that room? क्या होगा अरीबा?
Bomb फट जाएगा.
Yes, the same thing happens there. Before that, all the kids are there, but there is a huge space for them. So they would have less collisions. I mean, their rate of collisions will be small enough. But when the students are, I mean, the kids are put in the small room, same number of kids with same energy. कोई नहीं कुछ नहीं किया हमने. They have same energy, right? Then what will happen? They would have frequent collisions, more collisions. So when they will have more collisions, they will be having high pressure. ठीक है ना? That's the only reason. So I'm going to just write a simple statement here that during this all the pressure is increased. Pressure is increased by reducing the volume because should I spoil the beauty of this slide? Should I write on that one? So will you people get it?
Yes, sir.
Yeah.
Go for it.
At the constant pressure, constant temperature, at the constant temperature, which color would be more visible here? Okay, at constant temperature, the kinetic energy of the molecules will not change. complain cell. Kinetic energy of molecules will not change, only the number of collisions due to less space, the number of collisions are increased due to less space. Are you getting it?
Yes, sir.
Yeah.
Is it clear to all?
Yes.
Yes, sir.
आप इनके साथ बातें करो. Okay जी. Is it clear?
Yeah.
Okay. So the kinetic energy of the molecules is constant. I have mentioned this over here, but the volume of the air decreases. So frequency of molecules, air molecules collision increases. That is why pressure of the air increases. Oh my God. ये सारा मैंने यहाँ पे mention किया, but okay, no problem at all. That is simple. So this is an additional situation. This is called Charles' law
Sir.
that deals with volume increases with temperature as temperature increases. So that is very simple. You have to keep this
Sir.
point with you. It is not required that much discussion. But only thing, one thing what I wanted to explain to you, you people would be given a sort of graph, and that graph will be
Sir, I have a
that.
question.
Yes.
Do we have? I mean, do we have the equation of Charles' law in our syllabus?
No. That is not. That is why I was just saying that it is not mandatory for you to recall that. Only thing you will take care of in your any stage of your physics life, that V1 divided by T1 is equals to V2 divided by T2, and pressure, if pressure is kept constant. So because the volume is directly proportional to temperature, that's it. The only thing you have to recall from here. Okay.
Mm.
Okay. So the reason behind that is, this is actually what I wanted to explain you. You will see the comparison. If you do not change the volume, right? Unfortunately, in this diagram, he has changed the volume also. But if you do not change the volume, you know what happens? The on heating, the molecules would have more kinetic energy. Molecules will have more kinetic energy, and when the molecules will have more kinetic energy, their temperature would increase, and when their temperature will increase, they will push this piston upward. They will work on that piston, and when they will work on that piston, their volume would, they will increase the volume. Got it? That's the simple reason. Is it clear?
There.
Okay.
Yes, sir.
So this is basically pressure and temperature. Again, I told you that when we keep the volume constant by heating the molecules, their frequency of their frequency of collision is increased, right? Why? Because they are more faster. So when the kids are moving slowly in a small room, there is less chance of collision. But if the kids are running out, I mean not running out, sorry, running around the room, then what will happen? The collision would be more, is it? The same goes here. If you have these all molecules, and these molecules are having more motion, faster motion, there is a chance of more collision that will increase the pressure. So that is just a side information. You will take care of this, and I think so that we have to discuss this evaporation in the next lesson. Okay, because it is discussed to be in detail. Let me check. Don't move away. Let me check. Yeah, if you people have 5 more minutes, so I would be able to explain the mechanism, and rest all the slides are the past paper questions. So should we?
Okay.
Up to you, sir.
Okay, it's up to me, so I'm going to finish it up. तो जब आप लोग ये बोलते हैं ना कि up to you, तो इसका मतलब ये था कि तुम लोगों का दिल नहीं है, लेकिन पढ़ाएंगे तो सही. देखो, evaporation is basically it's very simple mechanism that is the escape of liquid molecules from the surface. I mean, I just simply explain that escape of liquid molecules. You can add high energy molecules, okay, from surface, right? So evaporation occurs when the liquid below its boiling point. This is really important. I mean, evaporation takes place at every temperature, right? It converts into gas. For example, when you put your clothes at the roof to dry, so do they get dry when the water inside them is boiled? No, they get dry when when the when the water inside them is evaporated. Okay, are you getting it? देखो 100 डिग्री सेंटीग्रेड पे
Yes.
तो नहीं ना जाएंगे आप लोगों के कपड़े कि 100 डिग्री सेंटीग्रेड पे जाएंगे तो खुश्क होंगे. No, it is not. They will dry below 100 degree centigrade. So when they dry below 100 degree centigrade, it means they are evaporating. Okay, so it happens because some particles in the liquid move faster than the others. So when they move faster than the other molecules are unable to hold them on their surface, so they move from the surface. Is it? So they have yani more energy, so they cannot be attached with the other molecules, so those molecules get escaped. It is very simple. मैं आपको ऐसे बता देता हूँ. देखो, this evaporation takes place usually, you know, in your classes also. Those students who don't want to take class, they do not yani they do not care कि यार whose class is there, right? The class
Right.
other students cannot hold them. I mean, they would not be able to convince them कि यार आज class ले लेते हैं ना please. No, if they would be yani if they have the more energy, they will do that. But if they would not, they will be convinced, okay चल यार जैनब आप कह रही हो तो class bunk नहीं करते. But if they would have more energy and more power to escape, they will not be held by the others. So this is the same. Those molecules which have more kinetic energy, they would not be held by the other molecules inside the liquid, so they will move to the surface and escape. This is a simple mechanism. Check this one out. Those particles with high enough molecular kinetic energy, they escape from the surface of the liquid, and this forms the vapors above the liquids. So this is basically vapors formation means evaporation, and this evaporation has different factors. One is the temperature. So if you have more temperature, for example, when the cup of tea is hot enough, it would have more evaporation, faster evaporation, right? More molecules are there which are having very high kinetic energy, so they will leave that. Then secondly, area of the exposed surface. You know, this is that by which we yani this is that factor which is used to make your clothes dry. If you have if you have not spread your cloths, what happens? They would not dry properly, is it? Because evaporation will not take place.
Right.
और एक और भी काम तुम लोग करते हो जो तुम लोग अभी तुम लोगों को मैं समझाऊंगा तो तुम लोग कहोगे ओ माय गॉड. Usually we spread the liquid into a open container, just like a plate, saucer जिसको हम लोग कहते हैं. ठीक है? So what happens? what happens? बहुत तंग करिए. So it cools down. Being the cooler.
It
Is it
cools
clear?
down.
Yeah, it gets cooler. So that is one we make evaporation. And secondly, if we want to make the floors dry, what do? We spread the water by the with the help of wiper. ऐसे ही करते हैं ना?
Yeah.
Yes. उधर सारी फिजिक्स तुम लोग लगाते हो घर में, लेकिन बस पता नहीं होता फिजिक्स ही लग रही है. Okay. Third factor is humidity. So if the humid environment is there, evaporation is yani less. That is why in July, August, especially near monsoon, it would be difficult for us to dry the clothes. ठीक है? And temperature peak है मैंने आपको बताया, but humid environment will not let the molecules to evaporate. That is why drought is another factor which would enhance the evaporation. ठीक है ना?
Yeah.
Okay. Then motion of the air, that is the wind. आप लोग फ्लोर्स को ड्राई करने के लिए पंखा नहीं चलाते या फिर
Yeah.
चाय फूक फूक के पीते हो? That is basically motion of the wind. We really apply this evaporation in our daily life all the times. ठीक है ना? हम पंखा चला लेते हैं, फ्लोर एकदम से हमारा ड्राई हो जाता है, या हम जब चाय पी रहे होते हैं, लेट हो रहे हो तो वी जस्ट उसको विंड ब्लो करते हैं, एयर फूक फूक के पी रहे होते हैं, so that gets cooler. So that is what I will tell you about the pressure. Pressure is another factor. If the atmospheric pressure will be less, evaporation will be lower, because आपके पास already vapors are greater in the molecule, I mean in the air. That's why more molecules will not be escaped in the air. Then nature of the liquid, for example, if you people have the nail polish removers, thinner कभी खुला रखा आप लोगों ने? Never ना?
What?
Any liquid which is just like in the markers. Why did you not put, or why don't you put the markers open without cap?
Because they
Because
dry.
Dry.
yes, they have the liquids like spirit, we call it spirit, or thinner. That is basically volatile. Petrol volatile hai. So when you keep the petrol tank open, it would dry. Is it?
Oh.
Yes. Spirit use karte ho na, so spirit is basically volatile. So if you will keep the container open, it would dry, it would be finished out. So those liquids which are dense enough, honey ko jitna marzi din chhod do, it does not happen something to honey, but petrol ko wo ho jata. So those liquids which are having lower boiling point, they also evaporate more rapidly. So these were the factors. So evaporation causes cooling. That's why मैं जो जितने factors बता रहा था, actually we want cooling. We do not follow कि यार evaporation हो रही है जो मर्जी हो रहा है, but we need cooling. So molecules of the liquid यानी जब आप एरिया को स्प्रेड करते हो, यानी चाय ठंडी करते हो, तो क्या करते हो आप उसको एक बड़ी प्लेट में ओपन कंटेनर में डाल देते हो या बड़े मग में डाल देते हो, जिसका एरिया ज्यादा होता है तो जल्दी चाय ठंडी हो जाती है. सॉसर में डाल के पीते हो तो चाय ठंडी हो जाती है, फूक फूक के पीते हो चाय ठंडी हो जाती है. क्लॉथ्स को स्प्रेड आउट करते हो तो वो जल्दी ड्राई हो जाता है. सो दिस ऑल के आपने एवेपोरेशन बढ़ानी है. अब कूलिंग का क्या मैकेनिज्म है? देखो, एवेपोरेशन में दोज मॉलिक्यूल्स व्हिच आर हाई एनर्जेटिक मॉलिक्यूल्स, दे लीव योर लिक्विड. व्हेन दे लीव योर लिक्विड, द रिमेनिंग मॉलिक्यूल्स आर लेस एनर्जेटिक. यानी जब क्लास से शरारती बच्चा निकल जाता है तो पीछे वाली क्लास में सेटल डाउन हो जाता है ना. इट इज वेरी सिंपल, वेरी इजी टू अंडरस्टैंड. ठीक है ना? तो रेस्ट ऑफ द क्लास इज नाउ कूल डाउन. तो इसलिए those molecules which are high energetic, when they leave the molecule, when they leave the liquid, rest of the liquid is with small kinetic energy, average speed decreases, hence the temperature of the molecule decreases. तो इसलिए आप लोगों ने याद रखना, this is very very important slide for you all. ठीक है ना, कि आपके पास evaporation में cooling कैसे होती है. So you have to keep these all points in your mind. That's basically the graphical representation of that. That high energy molecules are evaporating. Then these are the medium energy molecules, and these are the low energy molecules. So low energy molecules are always in the bottom. So they are just in the chill mole, कोई tension नहीं होती इनको. So these are very high energetic molecules. ये जो आप कोई hot liquid उठाते हो ना, and you see कि there are some sort of steam above it. वो जो steam होती है ना, that is basically high energy molecules. They are escaping continuously. That's it. अब समझ आ गया?
Yeah.
Okay. So now it is all your past paper questions. I would send this file to you, and this is the entire chapter of yours. It is now over. So I promised you people that inshallah today in this class we will be able to complete one chapter. So it is done. So rest two chapters will take little time. So I will finish this